everyone. Welcome to your week 5 of your technical math course. This week we are covering Chapter 8. Chapter 8 is all about systems of linear equations and how to solve them. And so basically this chapter is broken up into 4 sections. The first 3 are the different ways that you can solve systems of equations. And the last section is some applications. So using them for the dreaded word problem. So the first section is going to talk about how to solve systems of equations graphically. So before we even start with this section, I want to point out what exactly a system of equations is. So a system of equations is when we have 2 equations, both with an x and a y, and we want to find an answer that's going to make both equations true at the same time. So that's what we're trying to do. We're trying to find one solution that works in both equations. So that's what we mean when we talk about solving a system of equations. So the first method that they're going to talk about, and we're going to go through, is how to solve it graphically. And graphically is really not the best way to solve a system of equations, but sometimes it is a good visual way to determine if you're in the right ballpark, so to speak. So here are 2 equations. The first one is y equals 3x plus 1, and the second equation is x minus 2y equals 3. And so what you're going to do when you solve a system of equations graphically is you're just going to graph both equations. And so you can do that using whatever method you want. You can make a table. You can use the point slope method where you're looking at the intercept, and then you use the slope, which is what they did here with the y equals 3x plus 1. The 1 is the y-intercept, and then from there they counted the up 3 and over 1 to give you a point on that particular line, and then they graphed that line. Okay, so that's how they got the purple line. And then the blue line, it looks like they just found the 2 intercepts and plotted those. But the idea here is once you graph these 2 lines with whatever method you choose, what you're looking for is where do they intersect. So right here is where they intersect. So this point, -1, -2, is the solution to this system. So in other words, it's the one point that will work in both equations. And so my next several slides then, and you can review some of these on your own, will go through and show you how to find that point. And then we also look at, well, what happens when you graph and you don't have any points in common? Here's an example where if they have the same slope but different y-intercepts, they're not going to have anything in common. They're going to be parallel lines. So that's one benefit of graphing to find a solution, is you can see if the slopes are the same and the y-intercepts are different, that they're not going to have any points in common. So that's another type of use for this particular method. The other reason you might want to use this method is if you have 2 equations such as these 2, where once you graph them, you find that they are the same line. So they don't look exactly the same, but once they're graphed, you see they are the same line. So that means everything will make these 2 work. So those are just different ways that graphing is important. And these are just a summary of the different ways that you can come up with solutions when you are graphing. So you might get one solution, you might get no solution, and that's when they're parallel, or you might have an infinite number of solutions, and that's when they are basically the same line. So those are some of the things that you can find when you are graphing systems. Then the next thing that we're going to be looking at is solving by using what's called the addition method, or in other books you'll hear it called the elimination method. And the idea is to get rid of one variable and solve for the remaining variable, and then going back and plugging in to find the missing piece. So that's what the addition method is all about. And I'm not going to get into a lot of detail about that because my slides give you a lot of information about how to do that. This is just one example of how you can use the elimination method. You can see that we have two equations here, equation number 1 and equation number 2. And if we combine these, you can see how the 3 y's are going to go away. One's positive and one's negative. And if you add these two equations, which is why it's also called the addition method, we can get rid of that y term. So here's how that happens. Notice that when you combine, the y's go away and you're left with just 5x. And then 8 plus 7 is 15. So now we can easily solve for x. Once we know x, we plug that value back in for y, or for x, and solve for y, and then we have an ordered pair. Of course, we always want to check it, and so they go through the checking steps as well. The third method that I want to point out to you is what's called the solving by the substitution method. And what this one involves doing is solving one of the equations for one variable and plugging that expression into the other one. So let me give you an example here. Notice we have two equations, x equals 3 minus y, and then we have 5x plus 3y equals 5. Notice that the first equation is already solved for x. So what they're going to do is they're going to take this whole expression, this 3 minus y, and they're going to substitute it into the second equation for x. So they took the 3 minus y and they put it in this second equation in place of x. Then they went ahead and, they expanded, they used the distribution law, and they solved for y to get y is equal to 5. Then we go back and we put that y equals 5 into the original equation, the very first one, and we solve for x, and we can come up with a solution that way. So there's 3 different ways ultimately that you can solve a system of equations, and this is kind of a summary of all of them. You can do it graphically, you can do it by substitution, and you can do it using addition and or elimination, however you want to call that. And these are just some of the pros and cons of each. So as we go forward and you start to work on the applications, just know that you can use any of these 3 methods, and some are going to be better than others. So just kind of keep that in the back of your mind. And as usual, if you go through this material and you have any problems or questions this week, make sure that you reach out to me. That's what I'm here for. And have a great week.